A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we are going to check how to assess the VB-SEM, that is, Variance-Based Structural Equation Modeling in SmartPLS. Now, we do CB-SEM, that is covariance-based SEM in AMOS. But when we try to do VB-SEM, we require a software known as SmartPLS. Now, there are certain assumptions for SmartPLS and there are other assumptions for conducting the analysis in AMOS. So depending on the nature of your data, in case the sample size is small, in case your data does not fulfill the multivariate normality assumption, then in that case you can go in for VB-SEM, that is done in SmartPLS. So first let us understand the concept behind VB-SEM, how it is done, and then later on we will do a practical in SmartPLS where I will show you how to assess the structural model in SmartPLS. Earlier, I have made a video on how to assess the measurement model in SmartPLS. You might like to go back to the playlist to check that video. CB-SEM or covariance based structural equation modeling and VB-SEM, that is variance based structural equation modeling, is also known as PLS-SEM, that is partial least squares SEM. They are two distinct approaches within the broader field of SEM. They differ in their underlying principles, assumptions, and typical applications. SEM in SmartPLS is a systematic process that involves checking for. So what all steps we need to check in for? We need to check in for multicollinearity. We need to check for evaluating the strength and significance of relationships between the constructs, assessment of the model's explanatory and predictive power, which is done through R square, F square, and Q square, assessing the practical significance of the relationships. So here we are talking in particular context to structural model assessment. I have already explained in my previous video how to do measurement model assessment in VB-SEM. So you might look to go back and check on how we check the reliability, the convergent and discriminant validity. That is all included in my previous video. In SmartPLS, SEM focuses on evaluating the relationships between the latent variables within a model. Key steps include assessing collinearity, path coefficient, R squared, effect size, and predictive relevance. These steps help determine the model's explanatory power and the significance of the hypothesized relationships. So these are the three measures or three parameters to assess the explanatory power of the model. The first is coefficient of determination, denoted by R squared, to determine the amount of variance in the endogenous or the dependent constructs explained by the model. Effect size, or also known as F square value, it indicates how much the R square changes when a specific predictor is removed from the model. That means an independent latent variable is removed from the model, then how much is the change in the R square value. So small effect size is denoted by 0.02, medium is denoted by 0.15, and 0.35 denotes large effect size. Predictive relevance or Q square value, to assess the model's ability to predict new data points. It is a measure of out of sample predictive power and it is calculated using blind folding procedure. I will of course be discussing with you the blind folding procedure, especially a video on how to assess the predictive relevance of the model, the Q square value through the blind folding procedure in the upcoming video. These are some of the useful resources which you must refer to learn more about conducting your data analysis through VB-SEM in SmartPLS. Now let us go to the SmartPLS software and see how actually this process of structural model assessment is carried on. So here we are in our SmartPLS software, and we are going to build the model first. So FQ food quality has 4 indicators. I'll press the shift button and I click on FQ1 and FQ4, and then I take them over to the canvas like this. Simple. Then I click on CA1 till CA4 by pressing the shift button and then carry them over here. Similarly for SQ service quality, I click on SQ1, press the shift button and then click on SQ4. So I take SQ latent variable also. Similarly, I take the VM value for money. So this way I take my latent variable value for money in this canvas sheet. And now the dependent variable, which is the behavioral intention, I take it also to my canvas. Now to rotate the indicators, I select align indicators right. So like this, I shifted them to the right and I just make them look good like this: food quality, cultural authenticity, service quality, and value for money. Like this, I name them, right click, rename, and FQ, that is food quality, CA, that is cultural authenticity, third is service quality, SQ, fourth is VM, value for money. Like this, I rename them, and now I need to connect them. How to connect them? Click on this single headed arrow and connect it like this. Click on the single headed arrow and take it from all the exogenous or the independent variables to the dependent or the endogenous variable. Now the model turns blue. That means it's ready to run. This is the data of 204 respondents. You see here 204 records are there, and we are doing VB-SEM. All these indicators are reflective in nature, and we are going to see how to assess this model. The first step is you run a PLS algorithm, that is for measurement model assessment, which I have shown you in the previous videos also. So the first step is to run the PLS algorithm. It's all okay. The settings are quite okay. Start calculation. So you get the construct reliability, validity, discriminant validity, collinearity statistics, VIF, and you also get the model fit measures over here. You see SRMR, chi-square, and NFI. Now I want to do the structural model assessment, which is carried on by bootstrapping procedure in SmartPLS. That is how it is quite easy and quite convenient to carry on the analysis even if your data exhibits non-normality, because we have a built-in procedure of bootstrapping to assess the structural model in VB-SEM. That is something very good of SmartPLS. So now I go to calculate, I click on bootstrapping, and once I click on bootstrapping, I have to select at least 5,000 samples. Generally, it's observed that 5,000 and 10,000 samples, which are recommended by researchers, it gives you a quite stable result. And then I have to click on complete bootstrapping instead of basic bootstrapping. Bias corrected accelerated bootstrap, BCA, two-tailed, and then I click on start calculation. You want to check on PLS, so that is okay. Weighting scheme, we don't need to change anything. So setup is okay, and now we select start calculation. So once I click on start calculation, you see how fast it processes, and I'll be getting the structural model assessment results such as path coefficients, Cronbach alpha, HTMT, and R square values. Here it's mentioned bootstrapping is a non-parametric procedure that allows testing the statistical significance of various PLS SEM. So now I got the results. Now the first thing is I check the path coefficients. So now you see here the path coefficients, confidence intervals bias corrected. So I need to click on confidence intervals bias corrected. Now these are the path coefficients you see here: cultural authenticity, food quality, service quality, and value for money. And this latent variable number 5 is my dependent variable behavioral intention. So the path coefficient for that is 0.214 and sample mean is 0.214 and 2.5% and 97.5%. That means 95% confidence interval. Now I have to see whether 0 falls in between this value of 2.5% or 97.5%. In case a 0 falls in between, then this relationship is insignificant, and I would say there's no relationship between these two variables, the independent and the dependent variable. But in case 0 does not fall in between, I would say that it is a significant relationship between them. So that is how I check them. So now I'll go to, there's no indirect effects because I don't have a mediator in my model, right? I can go to outer loadings to check the outer loadings, which I did in my measurement model assessment. So that was well carried on in my measurement model assessment. Now I go to R square value. So I see R square tells me that how much variance in the dependent variable behavioral intention is attributed by the independent variables. 0.384, which is multiplied by 100 to give us 38.4, and whether this is significant, yes, it is significant. So that is how I see. Then I want to see F square value. So if in case I remove any of the latent variables out of these four, then how much will be the change in my R square value? So that is known as F square value. So if I remove CA, the change will be 0.051. That means 5% change. If I remove FQ, that means 3% change. If I remove SQ, that means 16% change. And if I remove VM, it means 0.006 multiplied by 100, that means 0.6% change. So that is how I explain what is the effect of removing the latent variable from my model on the R square value of my dependent variable. So whether it would be significant, so this says that it would not be significant. Red values say it would not be significant because they are above 0.05. But if I remove service quality out of my model, the change in my R square value you see here, it's the highest change, 16% out of these all four. So it would be quite significant because the p value is lesser than 0.05. It's 0.022. So that is how I assess F square value. Now to assess the Q square value, you have to go to the blinds folding procedure, which I'll tell you in the next video. Now we see here the model which we have got displays the T values over here. You come to the left panel and you see inner model and outer model. Now the inner model means the relationship between my independent and dependent variables, and it is showing me the T values. In case these T values are above 1.96 or below minus 1.96, then I say that there's a significant influence of the independent variable on the dependent variable. So we see here in case of FQ, CA and SQ, all of these are above 1.96, but when I go to VM, it's 0.974, that is lesser than 1.96. So this would be insignificant relationship. So I can go here and change it to path coefficients and p values. Now you see that path coefficient is 0.150, that is the beta coefficient, and it is significant because the value of p is probability is p. P is 0.020, which is lesser than 0.05. Here it's 0.013, again lesser than 0.05. But in case of value for money, it is 0.330, that is higher than 0.05. That means this path coefficient 0.069 is insignificant. So that means there is no significant relationship between value for money and my latent variable, the dependent latent variable, which is behavioral intention. So that is how I check it. If I go to the outer model, I can see the outer weights, loadings, and the p-values. So you see here, I see the outer weights, loadings, and p-values. So what should I see? I see that the p-values are significant. They all are significant, right? They all are significant. They all are significant, and value for money, they all are significant. So the indicators which are contributing to the meaning of the latent variable, they are reflective of the latent variable, are having significant probability value, p-value, and they do contribute. So this is something which we checked in our measurement model also. Now, if I want to just see the outer weights, loading, and t values, I'll see it like this. So I can do a p-value and outer weights check or outer loadings. Now, in case these indicators were formative in nature, then I would check the outer weights. So that will automatically give me the outer weights. But here we have all reflective indicators, so it will give me the outer loadings, which I need to check, right? So this is how I check it. Now I clicked on p-values and I got it. And constructs is the r square. So I got r square, which is 0.384, which means 38.4% of the variance in my dependent variable is explained by the model. That means all these independent variables contribute to 38.4%, but VM is insignificant in that contribution, right? I can go to highlight paths and say use absolute values or relative values. If I say relative values, you see I clicked on relative values and it shows me that the highest contribution to the r square value of the dependent variable is by service quality, because this is the thickest line, and you see over here it's 0.370 is the beta coefficient, and it's quite significant. It's lesser than 0.001. So it has the highest contribution. That's why when I clicked on use relative values, this is the thickest line which I see over here. So this is how I assess my model. I assess the structural relationship between my independent and dependent variable when I work on variance-based structural equation modeling in SmartPLS. So I hope the session was quite useful and interesting for you, and you will definitely share it with your friends and faculty colleagues. Thanks, keep learning and keep watching for more.